our requirements. We need a right triangle. We need at least 2 sides. In order to find missing angles, we use something called inverse trigonometric functions. I'm going to show you what those buttons look like on your calculator in just 1 second. If I think about solving for the variable x, hold on, let me get rid of this. Oh, okay. If I think about solving for the variable x, right, and I have 5x equals 10. In order to solve this, I would do the inverse of multiplication. The inverse of multiplication is division, right, to divide by 5 on both sides. The inverse of addition is subtraction. The inverse of trig functions is called an inverse trig function. It has fancy names, but we're going to call it an inverse trig function, okay? It is not the same as division. It is not the same as multiplication, not addition, not subtraction. It's its own unique thing. So here's how we solve this. We see sine B. The capital B represents an angle. We know capital letters always mean angles. So if I'm trying to solve for that variable B, I need to get rid of the sign. Well, to undo a sign, the inverse of sine is called sine inverse. And it looks like this, sine with a -1, like as its exponent. But it's not really an exponent. So I'm going to do that to the left side to get rid of that sign. What I do to one side, I have to do to the other. So if I did sine inverse on the left, I also have to do sine inverse of the right side. So sine inverse cancels out sine. So I'm left with B equals sine inverse of 0.4848. And that's what we're going to type into our calculator. Everybody got that right now? Okay, so let's go ahead and go to our calculators. Make sure you're in the right mode. And then I'm going to type it in like this. Most of your calculators will have this button. It's the second button. It's usually a different color. You hit second, and then you're going to hit the normal button that we've been using for sine, but hopefully you see in little writing, it says sine -1. That's your button. We only use this button if we're solving for angles. So now I have sine inverse, and I'm just going to type in that 0.4848. And I got 28.999. We're going to round that to 29. Did anybody not get this in their calculator? So I'm going to call this 29. And then all of our answers, when we're solving for a capital letter, these are angles. Our answers are in degrees. Okay, so I'm going to rapid fire through the next 2. It's the exact same thing. The inverse of sine is inverse sine. The inverse of cosine is inverse cosine. So I'm going to do cosine inverse of both sides. That cosine inverse cancels out with the cosine. So all I'm left with is W equals cosine inverse of 0.6157. And that's what goes in my calculator. Again, I'm just going to hit the second and then the regular old cosine button. But now it should have a cosine -1. 0.6157. And I got about 52. Our answer should be in degrees. And then one more. Obviously, the opposite of tangent is going to be inverse tangent. So I'm going to do inverse tangent of both sides here. Tangent inverse cancels out tangent. All I'm left with is the W now. Tangent inverse of 19.0811. And that's what's going into my calculator. Second, tangent 19.0811. About 87. Any questions on this? We kind of understand the concept. I don't want to see anybody dividing by a tangent to get rid of tangent. The inverse of tangent is inverse tangent. So let's do the examples. I won't do all of them, but we got to go through some of them. We start these problems the exact same way that we start all the other problems that we've done so far. I'm going to first focus on an angle. The angle that I'm focusing on is the one that I'm trying to find. And then I'm going to identify the pieces that I have in this triangle. I have the piece across from my angle, so I know that's the opposite. And I have the piece that's across from my right angle, so that's the hypotenuse, which means which trig function am I using here? That should be sine, right? If I think about SOHCAHTOA. Maybe I'll write it up here so we have it. SOHCAHTOA. So that's sine. I'm going to write sine. Where do I have some room? Right here. Now, yesterday, what were we always putting right after the trig function name? The degree measure. Do we know the degree measure here? So what we're going to put instead is just x. Okay? Because we don't know the angle, we're just going to put an x. Then it equals my trig ratio, which is for sine, opposite over hypotenuse. The opposite is 6.5. The hypotenuse is 10. I need to see this setup step. After we get this setup step, the next step is to get rid of this sign because I want the x to be by itself. So to get rid of the sign, I'm using inverse sine, and I'm going to do it to both sides. Sine inverse of sine x equals sine inverse of this side was 6.5 over 10. That sine inverse cancels out the sign, so all I'm left with is x. So I'm typing into my calculator sine inverse of 6.5 over 10. Exactly like that. I'm going to show you what that looks like. Everybody got this part? So, second sine to get sine inverse. And then 6.5 divided by 10. If you want, you can close those parentheses to make it look nice and fancy. You hit enter. I got 40.5. Everybody got that? Our unit should be in degrees. Okay, you think we can do one? Let's do B together. What are we going to pick here? We want to pick tangent. Okay, so I'm looking at my angle. I know I have the opposite and I have the adjacent, so that is tangent. What comes right after tangent? X, because I don't know that angle. And then it equals what? 9 over 3. Opposite over adjacent. 9 over 3. If you want, because this one is so easy to simplify, you can simplify that to 3. It doesn't change your value, but you don't have to. As long as your final answer is whatever decimal it is, you're fine. To get rid of this, I'm doing inverse tangent. I know some of you don't want to write out this step every single time, so I'm going to write it like this time. I'm going to do tangent inverse of both sides. So that tangent inverse cancels out that tangent. I am left with, x equals tangent inverse of 9 over 3. At the bare minimum, what I want to see is your original setup. So that's my tan x equals 9 over 3, right? Okay, I want to see that original setup, and I want to see what you're putting into your calculator. So there should be 2 steps that I see at minimum for all of these problems. Does that make sense? So I'm going to put into my calculator tangent inverse of 9 over 3. And I got 71.6. Anybody having problems with this right now? We're good? Okay, let's do x equals 71.6 degrees. Do we feel like we need to do more of these simple ones? Or can I move on to the harder word problems? Okay. Flip it over. These ones get tricky. Now that we have all of the tools in our tool belt, it's going to ask us to do more complicated things. So in these first two examples, the first thing that we're going to do is find all three angles in the triangle. Does anybody know what all three angles in a triangle add up to? Always? 180. So any triangle that we have will always equal 180 degrees. Now, we specifically are always looking at right triangles, which means we will always have a right angle. What's the measurement of that right angle? Beautiful. Okay, so in this first example, example 3, let's go ahead and draw our right triangle with my right angle, and then I get to label that right angle as 90 degrees. That's already 1 out of 3 angles done. Okay? So that first angle, right angle. Second angle. We got to put in our stuff first. The hypotenuse is 5 inches long. And then it says the opposite side is 2 inches long. So let's pick an angle. Let's call that angle X because we don't know what it is. And then we'll call the opposite side to that 2 inches long. Everybody's got that set up? Okay. Now, how are we going to find that second angle? We're going to use our trig. Think about what pieces we have. Which trig function do we want to use here? Sine. I have the opposite and I have the hypotenuse. This is hypotenuse here. This is opposite here. So we're going to use sine of that angle, which we're going to call it x, equals opposite over hypotenuse, 2 over 5. Just like we did on the first page, we're going to solve this using inverse sine. So inverse sine of both sides. I'm going to write it like this, which leaves me with x equals sine inverse of 2/5, which if I go ahead and put that into my calculator, sine inverse, second sine, 2 divided by 5, 23.6 is what I got here. Okay, I'm going to put that right here, 23.6 degrees. So, the first angle in our triangle should be the right angle. The second angle in my triangle, I'm going to have to find using trig, inverse trig, just like I did here, inverse trig. The third angle in my triangle, I should never have to use inverse trig twice. How do I find that third angle? Exactly. I know all three angles have to add up to 180, so I'm going to subtract the two angles that I know, the 90 and the 23.6, to get whatever that third angle is. That third angle, 180 minus 90 minus 23.6, is 66.4 degrees. So that's kind of my process. One angle should be a right angle. One angle we're going to have to use trig, and the third angle we should just be able to subtract from 180. Any questions on that? We're going to do it again. Let's go ahead and draw our right triangle. This is our 90-degree angle. The adjacent side is 12 centimeters, and the opposite side is 8 centimeters. So I'm going to pick an angle. Let's label the adjacent as 12. And the opposite as 8. Which trig function do I use here? Tangent. So I want tangent x equals opposite over adjacent. 8 over 12. If you want, you can simplify that. That's fine. It's not too bad to simplify. Tangent inverse of both sides, which leaves me with x equals tangent inverse of 8 over 12. Everybody got that? Let's go ahead and plug it in. Tangent inverse, 8 over 12. I got 33.7. How do I find that last angle? Perfect. So then that final angle, when I subtract them from 180, gets me 56.3. Any questions on this stuff? I'm going to make it even one step harder. So now we know how to find all three angles. Now we're going to add in finding all three sides as well. So let's take a look at letter A. I want to do the easy stuff first. If I already know I have two angles, or if I already know I have two sides, I can use Pythagorean theorem or subtract from 180. There is still some cake left. Over on the back table. So, if I have easy stuff that I can do, I'm going to do that first. Do we see something easy? What's a freebie that I get in this problem? James? Z is a freebie because I already have two of these angles. I know that's 90 and I know that's 150. So 180 minus 90 minus 50 tells me that Z equals 40 degrees. That is a freebie. Okay, I'm going to label it in here so we have it all. Now I got to start working on the sides. If I already have one side, that's great. That should kind of be given to me. The second side, I have to use regular trig, and then I'll tell you about the third side. So the second side, it doesn't matter what angle you pick. You cannot pick this right angle, but you can pick any of the other two, 50 or 40. That's important. Don't pick the right angle. I'm going to pick this 50. Do we want to find x or y first? Probably x, right? Doesn't really matter, but let's find x. So 5 here is the adjacent side to 50, and x is the hypotenuse side to 50. So for that second side, I'm going to use cosine. Cosine of your angle equals adjacent 5 over hypotenuse x. And now this is just like what we were doing yesterday. To solve for that x, I'm going to multiply it over. X times cosine 50 equals 5. And now what do? I'm going to divide by cosine 50. We should never use an inverse, cosine, or sine, or whatever, unless we're finding an angle. So let's divide. Okay, divide by cosine 50. X equals 5 divided by cosine 50. We're going to put that in our calculator. 3.2. 5 divided by cosine 50. I got 7.8. Did we all get 7.8? What did you get? Okay, so 7.8 is what I'm going with. Okay, and now here's our freebie. We got our second side. Here's how we get our third side. I never want to do this trig twice. I can do it once with the inverse and once without the inverse. But when I'm trying to find the third side, what's the best way to find the third side of a right triangle? Pythagorean theorem. We're going to do a squared plus b squared equals c squared. Okay, so come back with me here. I've got a, I have b, and then I just said that this x was 7.8. That's c squared. So this is 5 squared plus y squared equals 7.8 squared. Do a little bit of math with me. 7.8 squared is 60.84. $60.84 minus 25. Oops. If I can get it, minus 25. There we go. 35.84. And then square root both sides. I'm going to do square root. Second square root of my answer. I got 5.98, which I'm going to round up to 6. Questions on that? Okay, so let's just recap. I'm not going to make us do this one again, but I just need to recap how we find sides and angles. Sides, angles. Your first side should probably be given to you. You should probably have at least one side. The second side, you're going to need to use regular trig, sine, cosine, tangent. Once you have two sides, you should not have to do trig again. You should just use Pythagorean theorem. Good? Angles. That first angle is 90 degrees. The second angle, you will probably have to use inverse trig, unless it's given to you, in which case you're lucky. But once you have two angles, the third angle, you subtract from 180. And that's how we solve these triangles. That's your, three-step method for sides and for angles. Any questions on that? I know, I just threw a lot at you.